In this video, we are going to solve problems on the topic whatever we have learned in the last video. Alright, so look at the first one. See what you have. You need to separate the variables and then you need to solve it, correct? Now here we are going to use the half angle formula of trigonometry. Okay, before you do it, you need to simplify. See, dy by dx is equal to 1 minus cos x by 1 plus cos x, correct? 1 minus cos x is 2 sine square x by 2 by 2 cos square x by 2, which is tan square x by 2. Now, you cannot directly integrate tan square, right? So, you can write this as, remember tan square theta is secant square theta minus 1. So, this becomes secant square x by 2 minus 1, right? So, dy by dx is equal to secant square x by 2 minus 1, or dy is equal to secant square x by 2 minus 1 into dx. Now we integrate. Alright, so that means integral of dy is equal to integral of secant square x by 2 minus integral of 1 dx. Of course, dx is there for secant square x by 2 also. So the LHS is going to become y is equal to secant square theta is what? Tan theta. So this is going to become tan of x by 2 into 2 tan x by 2 minus x plus c. So this is going to be the final answer for the first question. Fair enough? So whatever we have, the first one, simplify, then apply trigonometric functions, then solve it. This is how you are going to do it. Clear? Now let's do the second question. All right. Now the second one. See, dy by dx root of 4 minus y square. Right? So cross multiply and basically it's transposing. Okay. Dy divided by root of 4 minus y square is equal to dx. Integrate, because you have already separated the variables anyway. Integration, right? Dy by root of 4 minus y square. What is it? Isn't it sine inverse? So you have sine inverse of y divided by 2 is equal to x plus c, isn't it? So take it down the other side. X minus sine inverse of y by 2 plus c is equal to 0. Clear? Now you can do it this way. So this you can keep it as the final answer. Or there is one more way. That is, see, we have sine inverse of y by 2 is equal to x, right? As in x plus c is there. If you don't take the c for now, you can just call it as x. You can take the sine inverse on that side, you can get it as sine. Okay, that means you get y is equal to, see, I'll show you another one, which is very similar to this one. That is sine inverse of y by 2 is equal to x. So y by 2 is equal to sine x. Y is equal to 2 sine x plus c. The final answer c, we can write it here. Guys, this can also be considered to be the answer. I mean, it's not wrong as such, it is right. But it's always preferable to write it in the first format rather than the second. Okay, that's the only thing. It's more about the preferences rather than what is right or wrong. That's all. Fine. Let's come to the third question now. The third question, secant square x tan y plus secant square y tan x dy is equal to 0. Guys, take the dy side to the other side. As in the dy term, what you have, take it to the other side. That means you're going to have secant square x tan y dx is equal to minus secant square y tan x into dy, correct? Take all the y terms on one side, take all the x terms on one side. That means you have secant square x divided by tan x dx is equal to, that's going to be minus sign, minus secant square y divided by tan of y dy. Correct? Now you need to simplify this. Now we will start to use different trigonometric functions. Okay, different types of trigonometric functions to solve this one. So first thing what we are going to do here, see that secant square x is there, correct? Secant square x. Now you can change it into tan square x minus 1. Okay, that is going to be one way of solving it. All right. So you can write this as 1 plus tan square x divided by tan x minus of tan square plus 1 divided by tan y dy. Now individually divide. That means if you individually divide, you're going to get tan x plus cot x dx minus of tan y plus cot y dy. Correct? So this is what is going to happen for this particular question. Now guys, we can directly integrate because we know the value of integration of tan x, integration of cot x and all. Isn't it? Since we know this one, we can directly do it. Fair enough? Now let's do the integral. First let's integrate and then we'll get the sign. Alright? See, we have integral of tan x plus cot x dx minus integral of tan y plus cot y dy. Correct? What is integral of tan x? Minus log of cos x. Or you can also call it as log of secant x. So we have log of secant x, and what is integration of cot x? Log of sin x plus log of sin x minus of log of secant y plus log of sin y plus c. Correct? First, what we'll do, let's use the laws of logarithm and simplify this one. That means this is going to be log of secant x into sin x, first part, plus log of secant y into sin y is equal to c, right? Now, again, this, see, what is sin x into secant x? It's nothing but tan x. Makes sense? Because secant x is what? Secant x is 1 by cos x, sin x by cos x is tan x. Basically, what I'm trying to tell you is this secant x, make it as 1 by cos of x, secant y, make it as 1 by cos of y. So don't you think you'll get it as sin x by cos x? Tan x. This is going to become log of tan x plus log of tan y is equal to c. Now we can directly multiply them, isn't it? This is going to be log of tan x into tan y is equal to c. Now guys, again I'll tell you, you can stop it right here, or you can take e to the power of exponent power on both the sides, so that the log and the e power gets cancelled out. Finally, we can end up with tan x plus tan y is equal to e to the power of c. You can just keep it as it is, which basically is going to give us the final answer. That is also correct. This is also correct. Okay, so either you can keep it like this itself, or you can also write tan x into tan y is equal to e power c. This also you can write, but generally we don't write the other one. This is going to be the final answer. Fair enough? Now moving on, we are going to solve the fourth one. See the fourth question. Now you have e power x plus e power minus x dy. Push the dx that side is equal to e power x minus e power minus x dx. Right? Guys, we have to integrate this one, isn't it? So what do? You take dy, or you can take the dx part, alright? Take it this way. Dy is equal to e power x minus e power minus x divided by e power x plus this dx, correct? Now we'll do the substitution method. Of course, guys, you have to write the integral sign, okay? What you have is integral of dy and integral of this one, right? Now we do the substitution method, alright? See, what we are going to do now is take e power x plus e power minus x as t. Then you will have e power x minus e power minus x dx is equal to dt. Correct? One step substitution we can do. Now the question is going to become y. Of course, integration of dy is y. This is equal to integral of dt divided by t, which is basically log of t plus c. Correct? So y is equal to log of e power x plus e power minus x plus c. This is the answer for the fourth question. Fair enough? Now let's move on to the next one. See the fifth question. Again, guys, separate the variables, okay? dy divided by 1 plus y square is equal to 1 plus x square dx. Right? Integrate. Integral of dy. What is this one? Tan inverse of y. Correct? Is equal to x plus x cube by 3 plus c. Or you can write this as x plus x cube by 3 minus tan inverse of y plus c is equal to 0. That's all. It's direct integration, nothing more, nothing less. It's very, very simple. Just separate the variables, solve it, and done. Fair enough? Now, let's move on to the next question. See question 6. X power 5 dy by dx is equal to this. Separate the variables. Basically what I'm trying to say is, get that y power 5 to LHS, basically dividing. Take the x power 5 and the dx on the other side. Okay? See, you're going to get dy by y power 5 is equal to dx divided by x to the power of 5, right? So you have minus y to the power of minus y dy is equal to x to the power minus 5 dx. Integrate, directly integrate, nothing more, nothing less, very simple. Alright, see, when you're integrating, you have minus y to the power minus 4 by minus 4 is equal to x to the power minus 4 divided by minus 4 plus c. Correct? Take the x, so here minus minus cancels, it's going to become positive. Take the one on the RHS to the LHS. You have y to the power of minus 4 divided by 4 plus x power minus 4 divided by 4 is equal to c. Okay, now if you want, you can write y power minus 4 as 1 by y power 4, or x power minus 4 as 1 by x to the power of 4, or you can keep it as it is. So this is going to be the answer for the sixth question. Fair enough? Now let's do the seventh question. See the seventh question. See what you have in this question, basically dy is equal to sine inverse of x dx, correct? Guys, It's basically integration of inverse trigonometric function. Do you remember how we used to do it? Take it as 1 into sine inverse of x, and then we apply the Eilert rule, correct? So we have integral of dy, integral of sine inverse of x into 1 dx, correct? So we have, what is integration of dy? Y is equal to, now the LHS is done. Now see the RHS, we have to take it as u and v. So here what do? You take this as the first function u, this function is v, correct? First is u into integral of v, sine inverse of x into x, correct? Minus integral of, first is what? U dash, correct? Which is 1 by root of 1 minus x square into v, which is x. Understood? Now, here we need to do the substitution method. Very, very simple. Okay, again, what do we do here? In this case, see this, the denominator will take it as t. That means we are going to take 1 minus x square as t minus 2x dx is equal to dt, correct? So, what do we have? We have x dx is equal to minus 1 by 2 dt. Substitute. That means, see, we have a minus sign, minus of, what is x into dx? Minus half dt divided by root of t. Correct. Half t power minus half dt. So, which is going to be 1 by 2 t to the power of half divided by half. Half and 2 cancels out. So, we end up with just t to the power half. Make sense? So, the first part is what? X into sine inverse of x plus root of 1 minus x square, isn't it? So, the final answer is going to be y is equal to x into sine inverse of x plus, that was root of t, root of 1 minus x square plus c. So, this is going to be the final answer for the 7th question. Okay, now we are going to solve the last one of this particular type. Alright, so let's do the 8th question now. See the 8th one. Now what do? We take the dy to the RHS. We have e to the power of x tan y dx is equal to, guys, rather than taking 1 minus e power x, we can, okay, so we can take it as e power x minus 1 secant square y dy. Yeah, split it. That means e power x by e power x minus 1 dx is equal to secant square y divided by tan y. Right? Now, what do? We integrate on both the sides. Integral, integral. Okay. Now, when you're integrating, remember we have to take substitution. We have to do substitution method here. That means take e power x minus 1 as t. Then e power x dx is equal to dt. Yeah, this is one. And for the next one, take tan y is equal to t. Sorry, we already have taken t. Let's call it as u. Then secant square y dy is equal to du, correct? So what do we get then? So we are going to get integral of dt divided by t. First part is equal to integral of du divided by u, right? Log of t is equal to log of u plus c. Make sense? Log of t minus log of u is equal to c. or log of t divided by u is equal to c, correct? Now directly substitute. What is t? E power x minus 1. What is u? Tan of y, correct? So if you substitute, the final answer will be log of e power x minus 1 divided by tan y plus c, sorry, is equal to c. Alright, so this is going to be the final answer. Fair enough. See, guys, in some of the problems I'm writing is equal to c, correct? In some of the problems we have taken plus c is equal to 0. It makes no difference actually speaking, because c is what? A constant, right? Constant can be positive, negative, whatever real number you can think of. So whether it's going to be plus c, whether it's going to be minus c, it makes no difference. So you might as well write it as is equal to c, or you can write it as plus c is equal to 0. I mean, mathematically they're one and the same. Fine. So these are one type of problems what you're seeing. In the next video, you are going to see one more type of problem.